Hey everyone, my name is Peter and welcome to my channel. I started it to explore the effects of space environment on plant growth. I'll be focusing on how plants are affected by microgravity, by different atmosphere, different soil and so on. And hopefully also I'll look into the economics of growing plants as food for astronauts and maybe some other uses of plants in space. The first experiment will be very simple. I will be taking a pre-grown plant and putting it in a wetless environment. To simulate microgravity, I'm using a device called the clinostat, which works by rotating a plant in a pot around its own axis, and this movement is then translated by the plant as microgravity. Now, if I place the plant horizontally like this, it simulates zero gravity, and depending on the inclination, I can simulate partial gravity, such as on the Moon or Mars, and so on. As plants, I will be using the spring cabbage seedlings. I will be growing one on the clinostat and one as a control sample for 2 weeks, and then comparing the new growth, that is the new leaves and new roots, to see if there's been any changing either in the morphology or the cellular structure. So here's everything set up with the plant on the clinostat and a control plant. I've also put a screen over the surface of the soil to stop it from falling out, but it has not been working as I expected. Let's see what the speed of the clinostat is based on this dash. Let's start now. So the optimum speed should be between 1 and 3 rotations per minute. This motor does 2 rotations per minute under no load. With the plant it should be slightly less, but still well within the needed value. Right now it's about 16 seconds halfway, so that's good. 25 seconds. 30, 32, 33 seconds, so that's perfect. To supply light, I'm using these 13-watt LED light bulbs with a photo period of 14 hours. That is 14 hours of sunlight followed by 8 hours of darkness, and I will be trying to establish experimentally exactly how much light the plant receives. So it's been 8 days since the beginning of the experiment, and I'm very happy to see that the plants are growing really well, because what I expected the most to happen was stunted growth, as the plants usually attribute the microgravity as a stress factor, which causes them to slow down their growth and put more energy into defense. The only yellow leaf died because it was always shielded from sunlight, but there have been no moldy soil or waterlogging, which I expected might happen due to no soil drainage. It's been 15 days since the start of the experiment, so I think it's about time to stop it and look at the results. For the plant on the clinostat, which started with 4 leaves, everything from this leaf upwards is new growth. For the plant on the clinostat, which started with 3 leaves, everything from this leaf onwards is new growth. So the first thing to notice is that the plant from the clinostat is tilted to the side. I think the only reason for this is that it became too heavy for it to be supported by its own stem, and as it was turning it was always pointing downwards, and it developed this tilt, but it did in fact experience microgravity, although it is something I will need to keep in mind for the future, and hopefully I will figure out a way to prevent this. One important difference to notice is the difference in height, which I did not expect. As you can see, the control plant is, let's say, 6.5 centimeters tall, compared to the plant from the clinostat, which is 10 centimeters tall, which is almost a 50% increase, pretty significant. The root systems also show some interesting differences. You can see there's very few roots on the bottom of the plant from the clinostat, compared to the control plant. And the obvious reason for this is that the water also experienced zero gravity. It didn't drain to the bottom, but it became saturated all through the soil, and the plant didn't have to invest energy into growing roots all the way to the bottom. At first, I wanted to look at the leaves under the microscope, even though I'm not expecting much change, but seeing as the biggest difference is in height, I think I'm going to look at the stems. What I'm expecting to see is a difference in the cell length of the stems. The plant from the clinostat should have longer cells, possibly thinner cortex, thinner cell walls. Here you can see the control plant. This is the cross-section through the stem with all the cells from the pith. But actually, if you look at the plant from the clinostat, you can see there's a big difference in the cell walls. This is the cross-section through the clinostat plant, and you can see all the cell wall, the thickened cell walls between the cells. Also, I believe the cells are less tightly packed. If you look back here, yeah, these cells are definitely much densely packed, and they're, I would say, smaller. So that's the mechanism behind the longer stem growth. Here's the cross-section along the stem. This is the plant from the clinostat, and you can see once again all the cells and the thickened cell walls between them. On the control plant, the cells are much thicker, the cell walls are much thicker, and I would say the cells are also more tightly packed as from the previous cross-section. And of course, the cell walls didn't have to be so thick on the plant from the clinostat because it didn't have to fight against the forces of gravity so much. I wouldn't say much about the cortex and the epidermis. To me, it pretty much looks the same. But I've noticed these tiny springs in what should be the xylem, that is the tubes that carry water from the roots to the leaves, and I'm ashamed to say I don't know what it is. I'll have to look it up. Okay, so it's actually the thickened cell walls in the xylem tracheae. It's obviously the second type, the middle type. Nevertheless, I never knew about it. So I think the experiment was a success, as the plant survived and showed more differences than I expected, and I learned that my clinostats can run 24/7 and my lights are more than strong enough. In a few weeks, I will be looking at how seeds germinate in zero gravity and if they can orient themselves at all. See you then!